So the next thing is the middle term of a binomial expansion. So the middle term of any binomial expansion may be raised to power n. Depends on n, yes. If n is even, it will have only one middle term. And the middle term is always n over 2 plus 1 is the middle term. I'll use the example to explain this. But if n is odd, it will have two middle terms. And it will be n plus 1 over 2 and n plus 1 over 2 plus 1. That's the middle term. Let me use the ones we've done. Remember our Pascal's triangle. You can see it. The middle term here is 2ab, which is the same thing as 2 over 2 plus 1. 2 over 2 is 1. 1 plus 1 is what? 2. So the middle term is the second term. Why, if this is 3 now, this is odd, we have two middle terms. See, as you can see. This is 1 and this is what? 2. Which is the same thing as 3 plus 1 over 2. 3 plus 1 over 2 is 4. 4 over 2 is 2. So the second term and 3 plus 1 over 2 plus 1. So 3 plus 1 is 4 over 2 is 2. So 2 plus 1 is 3. So the second and the third term are the middle terms. So it's very, very important. And the greatest coefficient of a binomial expansion, the greatest coefficient of any binomial expansion is the coefficient of the middle term. The coefficient of the middle term. As you can see, you'll be wondering, okay, assuming n is odd, it will have two middle terms, and would they be the same? Yes, they're always the same. And you'll be wondering, why is this so? Let me just show you okay. You see, this is odd. Okay, let's start with this. This one is odd. So the coefficient is 2. The middle term must be 2, which is coefficient of this and this 1, 1. So they are the same. But here, this is 2 even. The coefficient of the middle term is which is 2. 2 is the greatest. So 2, which is the middle term. And this is also 3, odd. 2 terms, second and third, are the greatest coefficient. So the coefficient of any binomial expansion is it must be the coefficient of the middle term. And you'll be wondering, why is this so? It's because of the combination formula that n combination r must be n combination n minus r. And that's what made it possible for them to have the same value. If you could remember our combination. So let's now apply this. We can solve some question we can apply binomial expansion in solving some of the questions, especially square root, nth root of any term, or maybe to approximate numbers. We can use it. It's very, very important. Example, if you are asked to find the cube root of 29, we can use the binomial expansion to solve this. Or maybe if you are asked to approximate 1.03 raised to power maybe 3, we can still use binomial expansion to do that. But let's review our binomial formula, that if you have a plus b, that is always n combination 0, a n b 0 plus n combination 1, a n minus 1 b 1 plus n combination 2, a n minus 2 b 2. So let's get something. If you could remember, this is 1, this is 1, 1, 1. So this is an plus n combination 1 is n. This is n minus 1 b1. While n combination 2 is n times n minus 1 over 2 factorial, if you could remember, using our binomial theorem. This is n factorial, n minus 2 factorial, 2 factorial. And we know we can write n factorial as n times n minus 1, n minus 2 factorial over n minus 2 factorial, 2 factorial. So that's how we got this. So let's finish up. A n minus 1 b. So a n, this 1, this, that's that, these 2, sorry. So it will continue this way, form a pattern. Minus 3. So let's stop here. Now if we make, if n is, if a is 1, you notice that the expansion is now 1 plus b raised to the power n. So our a is 1, so this is 1 plus this is 1, 0. So we have nb plus this 1, we have b what squared. So n minus 1, n minus 2, 3 factorial, b raised to the power what? 3. So that's how it will go. So this is a very important formula that will help us, if you ask to approximate some terms. Example, that the one I wrote, 1.03. 1.03 raised to the power, I think it's 3. Raised to the power 3. We can write it as 1 plus 0.03 raised to the power 3. So we split it, we've converted it to binomial. So where our a is what? 1 and our b 0.03. So we have, so using this is now 1 plus n is 3 times b 0.03 raised to the power 1, sorry, plus 3 times 2 over 2 raised to the power 2 plus, remember this is 3, so you must have 4 and 1, 2, 3. The fourth one is now 3 times 2 times 3 minus 1 over 3 factorial, which is 3 times 2. 0.03 raised to the power. So which is 1 plus this 0.09 plus 3 times that's square. So this is 3 times 0.0009 plus this is 0.03 cube which is 0.000027. Okay, this is 1 plus 0.09 plus 0.0027 plus 0.000027. So adding up this 1 point, so you can this 0909, so 092727. Okay, so that's our answer. So we can use it to find the power or the nth root of any expansion. Why the second one? Assuming if you're asked to find the cube root of 29, we can write the cube root of 29 as cube root of 27 plus 2. So remember, we can still write this as our aim is to use this formula 1 plus nb. So we'll write this as 27 plus 2 raised to power, using laws of indices, 1 over 3. And we can write this as we can bring this 27, so we can bring out this 27, 1 plus 2 over 27. And after, raise it to 1 over 3, because our main aim is to bring in 1 here. So which is now 27 1 over 3 plus 1 plus, times this times 2 over 27 raised to power 1 over 3. So as you can see, 27 raised to power 1 over 3 is 3. So we now expand this using our formula, which is 1 plus n is 1 over 3 times b. Our b is 2 over 27. I'm using this formula. I'm using this, so that's what I'm doing. Plus n is 1 over 3 times 1 over 3 minus 1 over 2 factorial, which is 2 over 27 squared. So plus, no need of, because we'll get more decimals, so let's just stop here. So this is 3, 1 plus 8, 2, this is 1 plus 2 over 81. This minus, so this should be minus half times 1 over 3 times minus, okay, it should be 2 over 3. 2 over 27 squared plus. So we know the half here was the half here, so we brought it here. This is 3, 1 plus 2 over 81 is 0.0247 minus, if you multiply all these, this is 0.0006. So we have 3. If you add this is 1.02212. No need of, because we'll get more decimals. So the answer is 3.07. Yes, 3.063. So that's it. That's the answer. So let's now enter the exam questions, real exam questions and their solutions.